Today's topic is exclusive OR gate. An OR gate recognizes words with one or more ones. The exclusive OR gate recognizes words with odd number of ones. Odd number of ones means odd parity words. A word in which one appears in odd number of times. Then only output is high. Odd parity words produces high output, while even parity words produces low output. This is the truth table for exclusive OR gate. What is the difference between this truth table and the truth table of OR gate? Can anyone tell what is the difference between this truth table, which is for exclusive OR gate, and the truth table for OR gate? The difference हाँ हाँ बस यही डिफरेंस है केवल. Only difference in the last, when inputs A and B are 1 1, in OR gate we get output 1, but in this exclusive OR gate we get output 0 for the case when inputs are 1 1. This is for even number of times. If inputs are 1 for even number of times, then output is 0. When input have 1 for odd number of times, then output is 1. In case second and third, when A is 0 and B is 1, or when A is 1 and B is 0, in these two cases input is 1 for odd number of times, and for these two cases output is 1. So this define exclusive OR gate, which recognize input words with which have odd parity words, which have words with odd number of ones. And this is the logic circuit for it. A and B are two inputs. A is connected to a NOT gate which produces A bar, and this A input also goes to lower AND gate. Similarly, B is also connected to a NOT gate which produces B bar, and B is connected to upper AND gate. Upper AND gate will produce output. What will be the output of upper AND gate? Its inputs are A bar and B. So output of upper AND gate will be A bar B, A bar dot B, which we can write only as A bar B. Similarly, the output of lower AND gate will be A B bar, because its inputs are A and B bar. So outputs of two AND gates are A bar B and A B bar, and these two outputs are given to a OR gate, and output of this OR gate now will be Y equal to A bar B plus A B bar. And this circuit is the symbol of exclusive OR gate, which is this logic circuit, and symbol of this logic circuit is shown in this figure. This is symbol of OR gate with one additional line at input, and this is the truth table for this exclusive OR gate. Output is high when inputs have 1 in odd number of times. When input have 1 in even number of times, then output is 0. A word equation for exclusive OR gate is, exclusive OR gate के आउटपुट को हम इस तरह से लिखेंगे, y equal to a XOR b. XOR is for exclusive OR operation, and its symbol is shown in this figure. Y equal to a plus b, and there is circle around plus sign. This circle around plus sign represent XOR operation. Read as y equals a XOR b. इस तरह के इक्वेशन को हम इस तरह से पढ़ेंगे, y equal to a XOR b, because the circle around plus sign represent XOR operation. The following figure shows 4 input XOR gate. There are 4 inputs, A, B and C, D. And output of this logic circuit will be A XOR B XOR C XOR D. And the symbol of XOR gate with 4 inputs is in this figure. Now we consider this question: what is the output of the following figure for each of these input words? There are 2 input words given having 16 bits: 1010, 1100, 1000, 1100. And in second case, this input word is 16-bit word again, and now it is 1010, 1100, 100, 1101. And this is exclusive OR gate. This is the symbol of exclusive OR gate. There are 16 input bits. If input bits are these, question number A, what will be the output of this XOR gate? So for XOR gate, we want its output. What is its output? We see how many times 1 appears in its input. This word has 7 ones. The word has 7 ones, which is an odd number. Therefore, the output from this exclusive OR gate is ODD, odd, equal to 1. Output of this gate is represented by odd, and this output odd is equal to 1 because in this input word 1 appears 7 times, which is an odd number. In this second part, how many times 1 appear in this word? It appears 8 times, which is even parity word. So output of exclusive OR gate that is represented by odd will be 0. This is an example of odd parity tester. We can test whether parity of input word is odd or even. If parity of input word is odd, then output is 1, and if parity of input word is even, then output of this exclusive OR gate will be 0. Next question is, what does the circuit of following figure do? This is the circuit. There are two inputs, one is A and other is represented by invert, and output is Y. Invert may be 0 or 1. If invert is 0, then what is the output Y? If invert is 0 and A is also 0, then output Y is 0. When invert equal to 0, A equal to 0, Y equal to 0 plus 0, 0 XOR 0, which is equal to 0. And when invert is 0 and input A is 1, input A may be either 0 or 1. So we first take the case when invert is 0 and input A is, once it is 0 and second time it is 1, then we get output Y as 0 XOR 1 equal to 1. So when invert is 0, output Y will be same as A. So Y equal to A when invert is 0. Similarly, if invert is 1, then we see what will be the output when A is 0 and when A is 1. When invert is 1 and A is 0, output of this XOR gate will be 0 XOR 1, that is 1. And when invert is 1 and input A is 1, output of XOR gate Y equal to 1 XOR 1, that is 0. So we see that when invert is 1, output Y will be complement of A, that is A bar. So Y equal to A bar when invert is 1. So what does this circuit do? If we keep invert 0 in this circuit, output will be same as A, and when we keep invert equal to 1, output Y will be equal to A bar, that is complement to A. Now we see what is the controlled inverter. Controlled inverter is a circuit that transmits a binary word or its ones complement. Ones complement of a binary word is obtained by complementing each bit of it. Complement of a word is obtained, that is known as ones complement, if we complement each bit of word. A word contains many bits. If we complement each bit, we find ones complement word. Now controlled inverter, circuit of controlled inverter is shown in this figure. This figure shows a 8-bit register which produces 8 bits from A0, A1, A2, A3, A4 up to A7. And these 8 bits are given to these 8 XOR gates, and output of XOR gates is represented as Y0, Y1, Y2, Y3 up to Y7. And an invert signal is applied at each of these XOR gates. So there are two inputs. in each XOR gate. One is the invert signal, which is common to all XOR gates, and other are A0 for first XOR gate, A1 for second XOR gate, A2 for third, and so on. Now if invert is 0, output Y0 will be equal to A0, output Y1 will be equal to A1, Y2 will be equal to A2, and output from of this circuit produces the same word A7, A6, A5, A4, A3, A2, A10. It is the same. Output word is Y7, Y6, Y5, Y4, Y3, Y2, Y1, Y0. It is the same which word, that word which is stored in 8-bit register, and that is A7, A6, A5, A4, A3, A2, A1, A0. Now when invert is 0, this is the case. Now when invert is 1, we get output Y0 as A0 bar, output Y1 as A1 bar, output Y2 as A2 bar, and so on. So the output word now obtained will be the ones complement of the word that is stored in this 8-bit register. And if invert is high, output word now will become A7 bar, A6 bar, A5 bar up to A0 bar. The output word from a controlled inverter equals the input word when invert is low, and output word from a controlled inverter equals to ones complement of the input word when invert is high. So this circuit works as controlled inverter. We can find the same word by keeping invert low, and we can find complement of this word, ones complement of this word, by keeping invert as high. Next gate is exclusive NOR gate. Previous one was exclusive OR gate, and now we consider exclusive NOR gate. The exclusive NOR gate, which we write as XNOR gate, is logically equivalent to an XOR gate followed by an inverter. So an exclusive OR gate, XOR gate followed by a NOT gate, this forms exclusive NOR gate. This is the logic circuit. A and B are two inputs, and we have XOR gate followed by NOT gate. This is the symbol for XNOR gate. This is the same as the symbol of XOR gate, except that this bubble is shown in this figure, and this bubble represents the NOT operation. So output is the truth table for this exclusive NOR gate is this. In the truth table of XOR gate, where we have ones, now we have zeros, and where we have zeros, now we have ones. Next topic is word comparator. Following circuit is a word comparator. It recognizes two identical words. If the words A and B are identical, all XNOR gates have high outputs, and the AND gate has a high equal. First we see the circuit diagram. This is the circuit diagram for word comparator, a circuit which compare two words, one word in register A and other word is stored in register B. Register A, which stores word A5, A4, A3, A2, A1, A0, and register B stores a word which is B5, B4, B3, B2, B1, B0. And these bits A0 and B0 are inputs of this exclusive NOR gate, output of which is Y0. Similarly, the bits A1 and B1 are inputs of this second exclusive NOR gate, output of which is Y1, and so on. And output of all these exclusive NOR gates are input of this AND gate, which produces output which is termed as equal. So output, what will be the output of this AND gate which is termed as equal? If the words A and B are identical, all XNOR gates have high outputs and the AND gate has a high equal. If words A and B differ in one or more bit positions, the AND gate has a low equal. So the circuit compare the two words. If equal is high, that is 1, then the two words are same, and if equal is 0, that is low, then two words are different. So this circuit works as word comparator.